Hi everyone, in this video we are going to discussing about aromaticity and antiaromaticity. These are the contents. Introduction. We all know that aromatic compounds which are planar, conjugated and which having uninterrupted pi electrons, mainly which obey 4n plus 2 pi electron, which is also known as Huckel's rule. Due to this aromaticity, compounds gain more extra stability due to resonance. Similarly, the homoaromatic compounds also exhibit aromatic behavior but in different manner. The main criteria for compound should be aromatic are compound should be cyclic, planar, conjugated and must obey Huckel's rule of aromaticity. Huckel's rule of aromaticity is the compound which contain 4n plus 2 pi electrons and where n is equal to whole number like 1, 2, 3 and 4 etc. Examples for aromatic compounds are benzene, cyclopentadienyl anion etc. Anti-aromatic compound, as like that of aromatic compound, anti-aromatic compounds should also have planar, conjugated and uninterrupted pi electrons, and the difference is which contain 4n pi electrons where n equal to 1, 2, 3 etc. Example for anti-aromatic compounds are cyclopentadienyl cation, which is planar, cyclic, conjugated and obey 4n pi electrons rule where n equal to 1. Now let us learn some of the compounds which obey aromatic, anti-aromatic and non-aromatic character. First example is cyclopropane, which is cyclic, planar but not conjugated. Due to presence of sp3 hybridized carbon atom, it is non-aromatic. Another one is cyclopropenyl cation, which is cyclic, planar, conjugated and which have 2 pi electrons, which obey Huckel's rule of aromaticity where n equal to 0. So it is aromatic in nature. Cyclopropenyl anion, which is cyclic, planar, conjugated and having 4n pi electrons where n equal to 1. So it is anti-aromatic in nature. In the same way, the 5-membered cyclic species cyclopentadiene, which is also cyclic, planar but which is not continuously delocalized pi electrons and which has one sp3 hybridized carbon atom. As we all know that aromatic or anti-aromatic compounds should having only sp2 hybridized carbon atoms, so it is non-aromatic in nature. Another one example is cyclopentadienyl cation, which is cyclic, planar, conjugated and having 4n pi electrons where n equal to 1, so it is anti-aromatic in nature. Cyclopentadienyl anion, which is also cyclic, planar, conjugated and having 6 pi electrons, obey Huckel's rule of aromaticity where n equals 1, so it is aromatic in nature. In the same way, the 6-membered cyclic species, as we all are familiar and favorite benzene, which is cyclic, planar, conjugated and each carbon atom is sp2 hybridized, so obeys Huckel's rule of aromaticity, so it is aromatic in nature. Conclusion. Why we need to study this aromaticity and anti-aromaticity? Because we has to know that stability of compounds and on the basis of which criteria the compounds get stabilized. The reason this aromatic character is also one of the criteria to say the molecule is stable or unstable. These are the references and thank you.